Imagine for a moment that everything you've been taught about our world is wrong. Picture yourself standing on an immense cosmic platter, flat, endless, and stretching out to the horizon in every direction. No gentle curve, no comforting sphere beneath your feet, just a colossal, disc-like Earth. For centuries, science has insisted we inhabit a round planet. The evidence is overwhelming. Photographs from space, the shape of Earth's shadow on the moon, and the unifying theory of gravity all tell us the same story. We live on a globe. But suppose, against all this knowledge, Earth were truly flat. What then? In this controversial thought experiment, we will cast aside the laws of nature as we know them, break the mold of accepted reality, and journey into a world where Earth defies its own physics. It is a world that might tempt conspiracy thinkers, yet one that, when examined closely, collapses under its own impossible weight. Let us start with the most fundamental challenge: gravity. Here, on our real Earth, every grain of sand, drop of water, and human body is pulled inward toward the planet's center. That's what gives us a roughly spherical Earth. But on a flat Earth, imagine a disk, a thin crust floating in space. The primary source of gravity, the planet's mass, would sit in the center like the hub of a wheel. The force pulling you down at the center might feel normal, but step toward the edge, and the direction of gravity would begin to tilt, like walking up a steepening hillside, constantly coaxing you back toward the center. Your body would feel heavier at your feet and lighter at your head, as if the very ground were conspiring to reel you back in. Without intervention, such a shape is gravitationally unstable. Over time, that disk would warp, buckle, and collapse into a sphere under its own weight. But say we suspend disbelief. Let's pretend some unknown force, holds this giant pancake in shape. How then would the atmosphere behave? We take for granted the even spread of air around our globe, but that distribution depends on spherical gravity. On a flat world, atmospheric gases would cluster thickly near the center, suffocating it with dense air. Move too far toward the outer rim, and the air would thin dramatically, leaving travelers gasping for breath. The sky might grow clearer, colder, and more hostile, creating extreme weather patterns that defy our notions of wind and rain. The rim, where the gravitational hold weakens, might struggle to keep any air at all. As you near the edge, you might be stepping into a near vacuum, a fragile frontier where gases leak off into space. Life as we know it would find no comfort in such extremes. Consider also the sun and the moon. On our spherical Earth, day and night occur because the planet rotates, presenting different sides to the sun's light. Seasons result from a tilted axis. On a flat Earth, achieving a simple sunrise or sunset becomes a puzzle. If the sun were a distant, brilliant star, it would shine on the entire disk at once, leaving no night. To create the illusion of day and night, you might have to conjure a sun that hovers close overhead, swinging in tight circles like a spotlight over a stage. Yet such a model is absurdly contrived. Would this local sun warp physics, changing size and brightness as it moved across the sky? Would it generate the same reliable patterns of dawn, midday, and dusk that we depend on? Without the familiar geometry of a rotating sphere, we face a glaring problem: how to establish stable, predictable cycles of light and darkness. And what about seasons? Those gentle shifts in temperature and weather that mark our passage through the year. Without a tilted globe spinning around the sun, there's no elegant reason for seasonal variation. Perhaps this hypothetical sun would need to dance above the disk, tracing different circles to produce changing climates. But such a dance would feel more like stagecraft than science, a carefully manipulated illusion that strains our credibility. Next, envision the oceans and continents. On a sphere, gravity tugs water into low basins we call oceans. Continents float atop tectonic plates that shift over a molten mantle, and the entire Earth is shaped by this interplay of forces. On a flat Earth, water would tend to collect at the center, drawn there by stronger gravity. The rim, far from the center's pull, would rise dry and barren. Instead of a neat global ocean encircling land, you might have a gargantuan central sea, ringed by scorched highlands. Tides, driven by the moon's gravitational pull, would falter. How do you lift and lower water when your gravitational field already bends awkwardly toward the center? The tides could become chaotic or disappear entirely, leaving coastal life in turmoil. Now dig deeper into this pancake Earth's layers, or rather, consider if it could even have meaningful layers. Our spherical Earth supports plate tectonics, driven by internal heat and a churning, molten mantle. These slow-moving plates create mountains, trenches, and the varied geology we see today. A flat Earth would lack the stable geometry needed for these processes. Without spherical symmetry, convection currents might break down. You'd have a strange, unpredictable geology. Maybe a few cracks here and there, but no grand system to build mountain ranges, no ordered cycles that recycle carbon and shape the land. Volcanic activity, how would that even work? It's all connected to a fluid, rotating core. Without a dynamic spherical interior, can you generate a magnetic field? Magnetism itself is another thorny issue. Our planet's magnetic field emerges from a dynamo effect in the molten iron outer core, generating a protective shield against the solar wind and cosmic radiation. Flatten that core into a disk, and suddenly you lose the coherent rotation and flows that sustain a strong, stable field. Without that field, charged particles from the sun would pummel the surface, eroding the atmosphere, mutating life, and transforming the planet into a hostile desert. Civilization would struggle to emerge or survive under relentless radiation. Celestial observations provide another lens through which this fantasy dissolves. On our spherical Earth, we see different constellations as we move north or south because we're on a curved surface. Ships vanish over the horizon, and distant mountain peaks rise from below the curve. On a flat Earth, where is that horizon line? How do we explain the disappearance of objects behind it? Everything would remain visible far into the distance, unless you introduce a contrivance of atmospheric distortion or other bizarre effects. Satellite orbits, too, rely on the neat geometry of a spherical mass. Without it, you cannot have stable orbits. Satellites would drift into space or come crashing down. The entire framework of spaceflight, the elegant physics that hurls rockets into orbit, collapses. And if this flat world is surrounded by a so-called ice wall or some boundary to keep oceans contained, that's yet another contrived element, lacking any natural explanation. On a real Earth, Antarctica forms a continent around the South Pole. On a flat Earth, you'd need to transform Antarctica into a continuous rim of ice encircling everything. But how did it form? By what geological miracle does it persist? Would the sun never melt it, or would it vanish into space? Every attempt to salvage a flat Earth scenario conjures more artificial scaffolding, more acts of cosmic theater that ignore the simplest, most elegant truth. Earth is round. This is the trouble with imagining a flat Earth. Each layer of our understanding, gravity, atmosphere, climate, geology, magnetism, orbits, is built upon fundamental physics that perfectly matches a roughly spherical world. Twist those physics to accommodate a flat world, and you end up with a carnival of contradictions. You must rewrite the laws of gravity, explain away basic observations, and invent convoluted patterns of light and dark. You must settle for a fractured atmosphere and a geological landscape that makes little sense. The scaffolding of flat Earth theory stands on nothing but the denial of established science and the rejection of obvious reality. Why then does the idea persist? Some say it's contrarianism, a desire to challenge authority. Others argue it's a misunderstanding of perspective and scale. Our everyday senses can be deceived. Our eyes see a flat horizon, and without global travel or spaceflight, we might never realize we're on a sphere. But scientific inquiry and evidence-based reasoning have corrected these illusions. Our round Earth model has survived centuries of scrutiny, from Newton to Einstein, from ancient Greece to the modern International Space Station. Every line of evidence, geodesy, astronomy, orbital mechanics, converges on the same shape. So, what if Earth were flat? In short, it couldn't be. Not without toppling the very pillars that support our understanding of nature. Such a world, if it could exist at all, would be a bizarre realm of unstable gravity, suffocating atmospheric distortions, nonsensical day-night cycles, and inconsistent weather. It would be a place where no permanent magnetic field guards against cosmic radiation, where no stable arrangement of continents and oceans nurtures life, and where the simplest astronomical observations fail to add up. Returning to reality, Earth, our precious home, is round. Within that shape, everything works in harmony. The geometry of gravity, the steady hum of plate tectonics, the dance of the sun and moon, the sheltering magnetic field, and the gentle arc of the horizon that cradles us all. This truth stands firm. And while it may seem controversial in certain corners of the internet, reality does not yield to whim. The planet's shape is no conspiracy. It is a natural conclusion drawn from centuries of careful observation and relentless testing. In the end, the flat Earth fantasy serves as a reminder. When we abandon evidence and reason, we enter a realm where nothing makes sense and everything must be contrived. Let us appreciate the elegant simplicity of a round Earth, the place that nurtures life and invites us to explore beyond its horizon, where the laws of nature remain intact and where the truth, like our planet, cannot be flattened.